Today, I invite you to explore the remarkable life of Max Planck, a man whose dedication to science transformed our understanding of the universe and laid the foundation for modern physics. His story is not only one of intellectual brilliance, but also of perseverance, curiosity, and an unwavering commitment to the pursuit of knowledge. Max Planck's journey toward becoming one of the most influential scientists in history began long before he introduced the revolutionary ideas that would transform physics. His early years were marked by a deep curiosity about the natural world, a strong educational foundation, and a family environment that encouraged intellectual growth. Understanding these formative experiences helps explain how Planck developed the mindset that eventually enabled him to challenge established scientific beliefs and open the door to the age of quantum physics. Max Carl Ernst Ludwig Planck was born on April 23, 1858, in Kiel, Germany. He entered a family that highly valued education, scholarship, and public service. His father, Wilhelm Planck, was a respected professor of law, while other members of the family had distinguished careers in theology, law, and academia. This atmosphere of intellectual achievement played a significant role in shaping the young Planck's outlook on life. From an early age, he was surrounded by discussions about knowledge, learning, and the importance of disciplined thinking. The Germany into which Planck was born was undergoing significant political, social, and scientific changes. The 19th century was a period of rapid industrial growth and technological innovation. New discoveries in chemistry, engineering, and physics were transforming society. Railways connected distant cities, factories increased production, and scientific institutions expanded their influence. Although Planck was still a child during much of this transformation, he grew up in a world where scientific progress was becoming increasingly visible. Such an environment naturally stimulated interest in understanding how nature worked. When Planck was still young, his family moved to Munich, a city known for its educational institutions and cultural life. The move proved important for his development because it provided access to excellent schools and teachers. In Munich, Planck attended the Maximilian Gymnasium, one of the region's most respected schools. There he received a broad education that included mathematics, languages, history, literature, and the sciences. Unlike some famous scientists who displayed dramatic signs of genius in childhood, Planck was known more for his diligence, consistency, and thoughtful nature. Teachers recognized him as a highly capable student who approached learning with seriousness and determination. He was not interested merely in memorizing facts. Instead, he sought to understand the underlying principles behind what he studied. This habit of searching for deeper explanations would later become one of the defining characteristics of his scientific work. During his school years, Planck developed a strong appreciation for mathematics. He found beauty in its logical structure and enjoyed solving complex problems. Mathematics appealed to him because it revealed patterns and relationships that seemed universal and timeless. The precision of mathematical reasoning fascinated him and provided a framework through which he could explore broader scientific questions. At the same time, Planck demonstrated remarkable musical talent. Music occupied an important place in his life from childhood onward. He learned to play several instruments, including the piano and organ, and possessed enough skill that some people believed he might pursue a professional musical career. He also enjoyed composing music and studying musical theory. For Planck, music was not merely entertainment. It represented harmony, structure, and order qualities that he also admired in science. The connection between music and science may seem surprising, but for Planck they were deeply related. Both fields required discipline, creativity, and an appreciation for hidden patterns. The same mind that enjoyed analyzing musical compositions also enjoyed exploring the laws of nature. Throughout his life, Planck continued to value music, often finding comfort and inspiration in it even during difficult times. As Planck progressed through school, his interest in physics gradually intensified. Physics offered a way to investigate fundamental questions about the universe. Why does heat behave as it does? What governs motion? How can natural phenomena be explained through universal laws? These questions fascinated him because they addressed the deepest workings of reality. One particularly influential teacher recognized Planck's potential and encouraged his scientific interests. Although physics at the time appeared to be a mature discipline with many major discoveries already made, Planck was attracted by the challenge of understanding nature at its most fundamental level. Rather than being discouraged by the belief that physics was nearly complete, he became motivated to contribute to its ongoing development. When the time came to choose a field of study at the university level, Planck carefully considered his options. His strong abilities in mathematics and music could have led him in several directions. However, he ultimately chose physics because it offered the opportunity to explore universal truths about the natural world. This decision would shape the rest of his life and ultimately influence the course of modern science. The decision was not entirely straightforward. Some professors advised him that physics had little left to discover. By the late 19th century, classical physics had achieved tremendous success. Scientists had developed powerful theories explaining motion, energy, heat, electricity, and magnetism. Many believed that only minor details remained to be resolved. A less determined student might have been discouraged by such advice. If all the major discoveries had already been made, why devote a career to the field? Planck, however, viewed the situation differently. He was not motivated primarily by the prospect of making famous discoveries. Instead, he was driven by a genuine desire to understand nature. Even if physics were nearly complete, he believed it remained a worthwhile subject because it revealed profound truths about the universe. This attitude reveals an important aspect of Planck's character. He pursued knowledge for its own sake rather than for recognition or personal gain. Throughout his career, this commitment to understanding would remain one of his defining strengths. It allowed him to persist through challenges and remain open to unexpected ideas. Planck's family also played an important role in nurturing these qualities. The values emphasized within his household included honesty, discipline, responsibility, and intellectual integrity. These principles influenced how he approached both life and science. He learned to respect evidence, think carefully, and maintain high standards in his work. The importance of discipline cannot be overstated when discussing Planck's development. Scientific breakthroughs are often associated with moments of inspiration, but they also require years of careful study and persistent effort. Planck's disciplined habits enabled him to tackle difficult problems that might have overwhelmed less patient individuals. From an early age, he learned that meaningful achievements require sustained dedication. Another significant feature of Planck's youth was his appreciation for certainty and order. He admired the idea that nature operates according to consistent laws that can be discovered through careful investigation. This belief inspired confidence that scientific inquiry could reveal deeper truths about the universe. Even when confronted with difficult questions, Planck trusted that rational analysis and experimentation would eventually provide answers. His intellectual curiosity extended beyond science. He read widely and developed interests in philosophy, history, and literature. These broader pursuits enriched his understanding of the world and encouraged thoughtful reflection about humanity's place within nature. The combination of scientific rigor and philosophical curiosity gave Planck a distinctive perspective that later influenced his approach to research. As he matured, Planck became increasingly aware of the challenges facing scientists. Many important questions remained unanswered despite the successes of classical physics. The behavior of heat, radiation, and atomic processes continued to puzzle researchers. Although these problems appeared highly technical, they pointed toward deeper mysteries about the structure of reality itself. At the time, neither Planck nor anyone else could have predicted that he would become the person who helped solve these mysteries. Yet the foundations for his future achievements were already being established. His curiosity, discipline, mathematical skill, appreciation for order, and commitment to truth were preparing him for the challenges ahead. The educational experiences of his youth also taught him the value of careful observation and critical thinking. Rather than accepting ideas simply because they were widely believed, he learned to examine evidence and evaluate arguments independently. This intellectual independence would later prove essential when he encountered scientific problems that could not be explained by existing theories. By the end of his school years, Planck had developed into a thoughtful and ambitious young scholar. He possessed a deep love of learning, a strong moral character, and an intense desire to understand the laws governing nature. These qualities set him apart and provided the foundation for his future contributions to science. Looking back, it is clear that Planck's later achievements did not emerge suddenly. They were the result of years of preparation, education, and personal growth. The environment in which he was raised, the teachers who encouraged him, the subjects he studied, and the values he embraced all contributed to the formation of one of history's greatest scientific minds. The story of his early life reminds us that great discoveries often begin with simple curiosity. Before Max Planck became the father of quantum theory, he was a young student fascinated by mathematics, music, and the mysteries of nature. His willingness to learn, question, and seek understanding laid the groundwork for achievements that would eventually transform humanity's understanding of the universe. The passion for knowledge that emerged during his childhood remained with him throughout his life, guiding him toward discoveries that changed the course of modern science forever. As Max Planck entered adulthood, the qualities that had been developing throughout his childhood became even more evident. His commitment to learning was not driven by a desire for fame or public recognition. Instead, he was motivated by a sincere fascination with the natural world and a belief that scientific inquiry could reveal the fundamental principles governing reality. This outlook distinguished him from many of his contemporaries and became one of the most important factors behind his future success. When Planck enrolled at the University of Munich in 1874, he began a more focused study of physics and mathematics. University life exposed him to advanced scientific ideas and provided opportunities to learn from experienced scholars. Although he respected his professors, he maintained an independent approach to learning. He carefully examined theories, asked thoughtful questions, and sought to understand the deeper meaning behind scientific concepts rather than simply accepting them at face value. At the university, Planck became particularly interested in thermodynamics, the branch of physics concerned with heat, energy, and their transformations. Thermodynamics was one of the most important scientific fields of the 19th century because it helped explain how engines operated, how energy was transferred, and how physical systems changed over time. The subject appealed to Planck because it combined mathematical precision with profound philosophical implications about the nature of order and change in the universe. One concept that especially attracted his attention was the second law of thermodynamics. This law describes the tendency of energy to become more dispersed and less available for useful work over time. Many scientists viewed it as one of the most fundamental principles in physics. Planck was fascinated by its universal nature and devoted considerable effort to understanding its significance. Unlike many students who focus only on passing examinations, Planck approached education as a lifelong pursuit. He spent long hours reading scientific papers, studying mathematical methods, and reflecting on theoretical questions. His intellectual discipline allowed him to master difficult subjects that required patience and persistence. These habits prepared him for the complex challenges he would later encounter in his research career. After completing part of his education in Munich, Planck continued his studies at the University of Berlin. This move gave him the opportunity to learn from some of the most respected physicists of the era. Berlin was a major center of scientific activity, attracting scholars from across Europe. Exposure to this environment broadened Planck's perspective and strengthened his commitment to scientific research. Among the prominent scientists whose lectures he attended were Gustav Kirchhoff and Hermann von Helmholtz. Both were internationally recognized for their contributions to physics. Although Planck admired their achievements, he sometimes found their teaching styles less inspiring than he had expected. Nevertheless, he benefited greatly from studying their work and gained valuable insights into scientific methodology. This experience taught Planck an important lesson. True learning often requires independent effort. Great teachers can provide guidance, but intellectual growth ultimately depends on personal dedication. Planck embraced this principle throughout his life. Rather than relying solely on classroom instruction, he pursued knowledge through study, reflection, and original investigation. His growing interest in thermodynamics eventually led him to select it as the focus of his doctoral research. Earning a doctorate required extensive independent work, and Planck approached the task with characteristic seriousness. He examined fundamental questions about energy and entropy, seeking to clarify concepts that many scientists considered difficult or controversial. Planck received his doctoral degree at a remarkably young age. Yet despite this achievement, he remained humble and eager to continue learning. He understood that obtaining a degree was not the end of education, but merely the beginning of a deeper scientific journey. This attitude reflected his lifelong commitment to intellectual growth and self-improvement. One of the most admirable aspects of Planck's character was his patience. Scientific understanding rarely develops quickly. Important discoveries often require years of effort, repeated failures, and careful analysis. Planck recognized this reality and accepted it willingly. He was prepared to devote long periods of time to studying difficult problems without immediate rewards. This patience became particularly important during the early stages of his academic career. Like many young scientists, Planck faced challenges in securing professional positions and establishing himself within the scientific community. Progress was sometimes slow, and opportunities were limited. However, he remained focused on his goals and continued refining his knowledge and skills. Another factor contributing to Planck's development was his strong sense of responsibility. He believed that scientists had an obligation to pursue truth honestly and rigorously. This ethical commitment influenced every aspect of his work. He avoided making exaggerated claims, carefully evaluated evidence, and maintained high standards of accuracy. Such qualities earned him the respect of colleagues and helped establish his reputation as a trustworthy scholar. Planck's love of learning also extended beyond formal academic subjects. He remained deeply interested in music throughout his life. Even as his scientific responsibilities increased, he continued to play musical instruments and participate in musical activities. Music provided relaxation and inspiration while reinforcing his appreciation for harmony and structure. Many historians have noted similarities between Planck's approach to music and his approach to science. In both fields, he sought underlying order and coherence. Just as a musical composition follows patterns that create harmony, Planck believed that nature follows laws that reveal deeper unity beneath apparent complexity. This perspective encouraged him to search for elegant explanations of physical phenomena. The combination of scientific rigor and artistic sensitivity made Planck a remarkably balanced individual. He understood that human knowledge encompasses multiple dimensions, and that creativity plays an important role in discovery. Scientific progress often requires imagination as well as logic, and Planck possessed both qualities in abundance. As he gained experience, Planck became increasingly convinced that the universe operates according to fundamental principles that can be discovered through careful investigation. This belief gave purpose to his work and sustained his motivation during difficult periods. Even when confronted with complex problems, he trusted that persistent effort would eventually yield understanding. The intellectual climate of the late 19th century also shaped his development. Many scientists believed that physics was approaching completion. The major laws of motion, energy, electricity, and magnetism appeared well established. Some researchers predicted that only minor details remained to be resolved. Planck did not fully share this confidence. While he respected the achievements of classical physics, he recognized that important questions remained unanswered. Certain phenomena continued to resist explanation, suggesting that deeper mysteries still existed beneath the surface of established theories. This awareness encouraged him to remain open-minded and attentive to unexpected possibilities. His willingness to question assumptions would later prove crucial. Revolutionary discoveries often emerge when scientists recognize limitations in accepted ideas and seek alternative explanations. Planck's intellectual independence prepared him to take this step when necessary. Although he respected tradition, he was not constrained by it. Friends and colleagues frequently described Planck as thoughtful, calm, and methodical. He avoided unnecessary controversy and preferred careful reasoning over dramatic speculation. These traits contributed to his effectiveness as a researcher. Rather than rushing to conclusions, he examined evidence patiently and allowed facts to guide his thinking. At the same time, he possessed considerable courage. Challenging established scientific beliefs requires confidence and determination. Even though Planck valued caution, he was willing to follow evidence wherever it led. This balance between skepticism and openness became one of his greatest strengths. The lessons learned during his youth remained with him throughout his career. The discipline developed in school, the curiosity nurtured by his family, the appreciation for mathematics and music, and the commitment to intellectual honesty all contributed to the scientist he would become. These qualities formed the foundation upon which his later achievements were built. It is important to remember that the groundbreaking discoveries associated with Planck did not arise in isolation. They were the culmination of decades of preparation. Every book he studied, every question he considered, and every challenge he overcame contributed to the development of his scientific vision. His success demonstrates the cumulative power of lifelong learning and persistent effort. For modern audiences, Planck's early journey offers valuable lessons. His story shows that curiosity can lead to extraordinary accomplishments when combined with discipline and perseverance. It reminds us that education is not merely the acquisition of information, but the cultivation of habits of thought that enable deeper understanding. It also illustrates the importance of maintaining an open mind while remaining committed to evidence and reason. By the time Max Planck completed the formative stages of his education, he had already established many of the characteristics that would define his career. He was intellectually rigorous, deeply curious, morally principled, and passionately committed to discovering the truths hidden within nature. These qualities prepared him for the scientific challenges that awaited him and positioned him to make contributions that would forever change physics. The passion for learning that emerged during his youth never faded. Throughout his life, Planck continued seeking deeper knowledge and greater understanding. His early experiences taught him that the pursuit of truth is a lifelong endeavor, one that requires patience, humility, and determination. Those lessons guided him toward achievements that transformed science and secured his place among the greatest thinkers in human history. As Max Planck completed the formative years of his childhood and adolescence, he entered a period that would shape him into one of the most influential scientific minds in history. His education and intellectual development were not merely a preparation for future discoveries. They were the foundation upon which his entire scientific career was built. During these years, Planck transformed from a talented student with a passion for learning into a dedicated physicist, committed to uncovering the deepest laws of nature. When Planck began his university studies in the 1870s, physics was widely regarded as one of the most successful sciences. The laws of motion established by Isaac Newton had explained countless physical phenomena for nearly 2 centuries. Advances in thermodynamics had revealed important principles governing heat and energy. Electromagnetism was rapidly developing into a comprehensive theory through the work of scientists such as James Clerk Maxwell. To many observers, it seemed that physics was approaching completion. Despite this confidence, Planck was drawn to the field because he believed it offered the clearest path toward understanding the universe. He was not interested in science merely as a collection of facts. He wanted to uncover the universal principles that governed reality. This desire guided his educational choices and influenced every stage of his intellectual development. At the University of Munich, Planck immersed himself in the study of mathematics and physics. He approached his coursework with exceptional dedication, carefully examining both theoretical concepts and experimental evidence. Unlike students who focused primarily on passing examinations, Planck sought a deeper understanding of the subjects he studied. He spent countless hours reading scientific literature, analyzing mathematical relationships, and reflecting on fundamental questions about nature. One of the most important characteristics of Planck's educational journey was his commitment to independent thinking. Although he respected the expertise of his professors, he did not accept ideas uncritically. Instead, he examined theories carefully and sought to understand their logical foundations. This habit of questioning and analysis helped him develop the intellectual independence that would later prove essential in his scientific work. During his studies, Planck became particularly fascinated by thermodynamics. This branch of physics dealt with heat, energy, and the laws governing their behavior. Thermodynamics occupied a central position in 19th century science because it helped explain processes ranging from steam engines to chemical reactions. More importantly, it addressed profound questions about order, change, and the nature of physical reality. The second law of thermodynamics especially captured Planck's attention. This law describes the tendency of energy to become increasingly dispersed within physical systems. It introduced the concept of entropy, which became one of the most important ideas in physics. Many scientists considered the second law a fundamental principle of nature, and Planck devoted considerable effort to understanding its implications. What attracted him to thermodynamics was not simply its practical applications, but its apparent universality. The laws seemed to apply everywhere, regardless of the specific details of a system. This universality resonated with Planck's belief that science should seek general principles capable of explaining a wide range of phenomena. He admired theories that revealed deep order beneath the complexity of the observable world. After studying in Munich, Planck continued his education at the University of Berlin, one of Europe's leading centers of scientific research. Berlin provided opportunities to learn from some of the era's most distinguished physicists. Among them were Gustav Kirchhoff and Hermann von Helmholtz, both of whom had made major contributions to physics and scientific methodology. Although Planck respected these scientists enormously, he later admitted that he sometimes found their lectures less inspiring than expected. However, this experience reinforced an important lesson. Genuine scientific understanding often requires self-directed learning. Even the greatest teachers can only provide guidance. True mastery comes from personal effort and intellectual engagement. Planck responded by intensifying his independent studies. He carefully read scientific papers, explored mathematical techniques, and investigated theoretical problems beyond the requirements of his courses. This disciplined approach allowed him to develop a deeper understanding than many of his peers. He learned not only existing scientific knowledge, but also the methods through which that knowledge had been acquired. Another significant aspect of Planck's development was his growing appreciation for scientific rigor. He believed that theories should be based on clear reasoning and supported by evidence. Speculation without justification held little appeal for him. This commitment to rigor became one of the defining features of his scientific style and contributed greatly to his credibility within the scientific community. As his studies progressed, Planck began conducting original research. Research differs from classroom learning because it involves confronting questions that do not yet have established answers. This transition marked an important stage in his intellectual development. Rather than merely absorbing existing knowledge, he started contributing to its expansion. For his doctoral dissertation, Planck chose a topic related to thermodynamics. The work required him to analyze complex theoretical issues and demonstrate his ability to conduct independent scientific investigation. Completing a doctoral dissertation demands persistence, discipline, and intellectual creativity. Planck possessed all these qualities in abundance. His dissertation reflected the seriousness with which he approached scientific problems. Rather than seeking quick results, he focused on understanding fundamental principles. This emphasis on foundational questions would remain a hallmark of his career. Throughout his life, Planck preferred investigating deep theoretical issues rather than pursuing fashionable topics of temporary interest. After earning his doctorate, Planck continued his academic training through a process known as habilitation, which qualified him to teach at the university level. During this period, he refined his research skills and deepened his expertise in thermodynamics. These years were crucial because they allowed him to establish himself as a professional scientist and gain experience in both research and teaching. Teaching played an important role in Planck's development. Explaining scientific concepts to students requires clarity of thought and a thorough understanding of the subject matter. By teaching physics, Planck strengthened his grasp of fundamental principles and learned to communicate complex ideas effectively. These skills later helped him present groundbreaking theories in a convincing manner. At the same time, he faced significant professional challenges. Academic positions were highly competitive, and opportunities for advancement were limited. Young scientists often spent years working in relatively modest roles before securing permanent appointments. Planck was no exception. Progress came gradually, requiring patience and perseverance. Despite these difficulties, he remained committed to scientific research. His passion for understanding nature provided motivation during periods of uncertainty. Unlike individuals who pursue careers primarily for financial rewards or social status, Planck was driven by intellectual curiosity and a genuine love of discovery. This dedication enabled him to continue working toward long-term goals even when immediate success seemed distant. One notable feature of Planck's scientific development was his preference for theoretical physics. While he appreciated experimental work, his greatest strengths lay in analyzing concepts, developing mathematical frameworks, and exploring the logical structure of physical theories. He enjoyed identifying underlying patterns and seeking unifying principles that could explain diverse phenomena. This theoretical orientation reflected his broader intellectual temperament. Planck valued order, consistency, and coherence. He believed that the universe operated according to rational laws, and that science could reveal those laws through careful investigation. This confidence in the intelligibility of nature gave direction to his research and shaped his scientific philosophy. His growing reputation eventually led to academic appointments that provided greater opportunities for research. As he advanced within the university system, he gained access to colleagues, resources, and intellectual networks that supported his work. These interactions exposed him to new ideas and encouraged continued growth as a scientist. Scientific development rarely occurs in isolation. Planck benefited from participation in a vibrant scientific community where researchers exchanged ideas, debated theories, and shared discoveries. Such interactions broadened his perspective and helped him remain informed about developments across multiple areas of physics. At the same time, Planck maintained a distinctive intellectual identity. He was not easily influenced by scientific trends or popular opinions. Instead, he evaluated ideas according to their logical consistency and empirical support. This independence allowed him to pursue research directions that others might have overlooked. The values instilled during his childhood continued to influence his approach to science. Honesty, discipline, and respect for truth remained central to his work. He believed that scientific progress depended on integrity, and that researchers had a responsibility to follow evidence wherever it led. These principles earned him widespread respect among colleagues and students alike. As the years passed, Planck's expertise in thermodynamics deepened. He became increasingly interested in the relationship between energy, radiation, and matter. These interests would eventually lead him toward problems that classical physics struggled to explain. Although he could not yet foresee the revolutionary discoveries awaiting him, the groundwork was being laid. The educational experiences and intellectual growth of these years were essential preparation for the challenges ahead. Through rigorous study, independent thinking, original research, and professional perseverance. Planck developed the skills and perspectives necessary for scientific innovation. He learned how to analyze complex problems, evaluate evidence, and remain committed to truth even when confronting uncertainty. By the end of this stage in his life, Max Planck had established himself as a capable and respected physicist. More importantly, he had cultivated the habits of mind that would eventually enable him to transform the field of physics. His education was not simply a period of acquiring knowledge. It was a process of intellectual formation that prepared him to question assumptions, confront mysteries, and contribute to one of the greatest scientific revolutions in history. As Max Planck's scientific career continued to develop, the knowledge and skills he had acquired during his years of study began to mature into a distinctive approach to research. He was no longer simply a student learning from textbooks and professors. He had become an active participant in the scientific community, contributing his own ideas and gradually establishing a reputation as a thoughtful and highly capable physicist. This period of growth was crucial because it shaped the methods and perspectives that would eventually lead him toward revolutionary discoveries. One of the defining features of Planck's scientific development was his extraordinary patience. Unlike some researchers who sought rapid recognition, Planck was willing to spend years studying difficult problems. He believed that a genuine understanding of nature required careful thought and persistent effort. This attitude often placed him at odds with the growing pressure for immediate results, but it also allowed him to investigate questions at a much deeper level than many of his contemporaries. During the late 19th century, physics appeared remarkably successful. Scientists had developed sophisticated theories describing motion, heat, electricity, and magnetism. New technologies based on these discoveries were transforming industry and everyday life. Yet beneath this success, several unresolved problems remained. Certain experimental observations did not fit neatly within existing theoretical frameworks. Although many scientists considered these issues minor, Planck recognized that they might reveal deeper weaknesses in classical physics. His work increasingly focused on understanding the fundamental laws governing energy. Energy was one of the most important concepts in physics because it connected diverse phenomena under a common framework. Whether studying mechanical motion, heat, light, or electricity, scientists frequently encountered energy as a central principle. Planck was fascinated by its universal character and sought to understand its behavior with the greatest possible precision. At the same time, he developed a growing interest in the interaction between matter and radiation. Radiation refers to energy that travels through space in the form of electromagnetic waves, including visible light. Understanding radiation was becoming increasingly important because new experiments were producing results that challenged existing theories. These challenges would eventually become central to Planck's career. Another important aspect of his development was his commitment to mathematical analysis. Planck believed that mathematics provided the most reliable language for describing nature. While experimental observations supplied essential data, mathematics revealed the underlying relationships connecting different phenomena. His ability to combine physical insight with mathematical rigor became one of his greatest strengths as a scientist. Colleagues often admired the clarity and precision of his thinking. Planck approached problems systematically, carefully examining assumptions and evaluating consequences. He avoided unnecessary speculation and preferred conclusions supported by strong evidence. This cautious approach sometimes made his progress appear slower than that of more adventurous researchers, but it also ensured that his work was highly reliable. As his reputation grew, Planck received increasing recognition within academic circles. He secured prestigious university positions and became involved in scientific organizations that played important roles in German intellectual life. These opportunities allowed him to interact with leading researchers from across Europe, exposing him to new ideas and emerging areas of investigation. Despite his growing status, Planck remained remarkably modest. He did not view scientific achievement as a path to personal glory. Instead, he regarded research as a service to knowledge and society. This humility earned him the respect of students, colleagues, and rivals alike. Many people who worked with him noted his integrity, fairness, and dedication to truth. Teaching continued to occupy an important place in his professional life. Planck believed that education was essential for the advancement of science. By training young physicists, he helped ensure that future generations would continue exploring the mysteries of nature. His lectures were known for their logical organization and intellectual depth. Students appreciated his ability to explain difficult concepts clearly while encouraging independent thought. The process of teaching also benefited Planck himself. Explaining scientific principles to others required him to examine ideas carefully and refine his understanding. This constant engagement with fundamental concepts strengthened his intellectual foundation and prepared him for increasingly complex research challenges. Throughout these years, Planck maintained a broad interest in scientific questions. Although thermodynamics remained his primary focus, he paid close attention to developments in other branches of physics. He understood that scientific progress often occurs when insights from different fields are brought together. This openness to diverse ideas expanded his perspective and enhanced his ability to recognize important connections. His intellectual growth was also influenced by philosophical reflection. Planck was deeply interested in questions about the nature of scientific knowledge and the relationship between theory and reality. He believed that science should strive to uncover objective truths about the universe, rather than merely provide useful descriptions of observations. This philosophical commitment shaped his approach to research and reinforced his determination to seek fundamental explanations. At a time when some scientists emphasized practical applications, Planck remained devoted to understanding basic principles. He believed that the most important advances often emerge from investigations driven by curiosity rather than immediate utility. History would later confirm the wisdom of this view. Many technologies that transformed the modern world were ultimately based on discoveries originally pursued for purely scientific reasons. Another characteristic that distinguished Planck was his resilience. Scientific research inevitably involves setbacks, failed ideas, and unanswered questions. Planck encountered many such challenges during his career, yet he rarely became discouraged. Instead, he viewed difficulties as opportunities for learning and growth. This resilience allowed him to continue working on complex problems, even when solutions seemed elusive. His persistence was especially evident in his study of radiation. Scientists had accumulated a growing body of experimental data concerning how heated objects emit energy. Existing theories struggled to explain these observations accurately. Many researchers attempted to solve the problem, but progress remained limited. Planck became increasingly interested in this challenge because it touched upon some of the most fundamental issues in physics. Initially, he approached the problem using the tools and concepts of classical physics. Like most scientists of his era, he believed that established principles would eventually provide the answer. However, as he examined the evidence more closely, he began to recognize inconsistencies that could not be ignored. The gap between theory and experiment suggested that something important was missing from the existing framework. These realizations did not immediately lead to revolutionary conclusions. Planck was naturally cautious and preferred to exhaust conventional explanations before considering more radical possibilities. Nevertheless, his willingness to confront difficult evidence demonstrated intellectual honesty of the highest order. He understood that scientific progress depends on following facts rather than defending preconceived beliefs. During this period, Planck's scientific maturity became increasingly apparent. He had developed the ability to balance respect for established knowledge with openness to new ideas. This balance is one of the most difficult qualities for any scientist to achieve. Excessive attachment to tradition can hinder innovation, while excessive enthusiasm for novelty can lead to error. Planck managed to navigate between these extremes with remarkable skill. His contributions to the scientific community extended beyond his own research. He actively participated in discussions, evaluated the work of other scientists, and helped shape the direction of physics in Germany. Through these activities, he influenced the broader development of the discipline and fostered an environment conducive to intellectual progress. The values that had guided him since childhood remained evident throughout his professional life. Discipline, curiosity, integrity, and respect for evidence continued to define his approach to science. These qualities not only enhanced the quality of his research, but also inspired those around him. Younger scientists often viewed Planck as a model of scholarly excellence and ethical conduct. As the 19th century drew to a close, the scientific world stood on the verge of profound transformation. New experimental findings were raising questions that classical theories could not fully answer. Many researchers sensed that significant changes might be approaching, though few anticipated their scale. Planck found himself at the center of these developments, equipped with decades of education, experience, and intellectual preparation. The years devoted to education and scientific development had prepared him exceptionally well for the challenges ahead. He possessed a deep understanding of existing theories, mastery of mathematical methods, extensive research experience, and a strong commitment to truth. Perhaps most importantly, he had cultivated the patience and courage necessary to confront problems that resisted conventional solutions. Looking back, it becomes clear that Planck's later achievements were rooted in this long period of intellectual growth. His groundbreaking contributions did not emerge suddenly or by accident. They were the result of years of disciplined study, careful reflection, and unwavering dedication to scientific inquiry. Every lecture attended, every paper studied, every problem analyzed, and every challenge overcome contributed to the formation of a scientist capable of changing the course of history. By the end of this stage in his life, Max Planck had become one of Germany's most respected physicists. Yet his greatest accomplishments still lay ahead. The knowledge, habits, and perspectives developed during these years would soon enable him to address one of the most perplexing problems in science. In doing so, he would open the door to a new understanding of nature and begin a revolution that would forever alter humanity's view of the universe. The birth of quantum theory at the end of the 19th century, physics appeared to be one of the most complete and successful sciences in the world. Scientists believed that the major laws governing nature had already been discovered. The theories of Isaac Newton explained motion, while the laws of thermodynamics and electromagnetism successfully described many physical phenomena. However, beneath this confidence, a significant problem remained unsolved. The behavior of thermal radiation also known as blackbody radiation, could not be fully explained using classical physics. A blackbody is an ideal object that absorbs all incoming radiation and emits energy depending on its temperature. When scientists studied the radiation emitted by heated objects, they found that experimental results did not match theoretical predictions. Existing equations worked well at some wavelengths, but failed dramatically at others. According to classical physics, a heated object should emit an infinite amount of energy at very short wavelengths, a prediction that clearly contradicted reality. This contradiction became known as the ultraviolet catastrophe. Max Planck became deeply interested in solving this problem. As a physicist specializing in thermodynamics and radiation, he carefully analyzed the available experimental data. For years, he searched for a mathematical formula that could accurately describe the observed behavior of blackbody radiation. Despite numerous attempts by scientists across Europe, no satisfactory solution had been found. In 1900, Planck made a bold and unexpected proposal. To match the experimental results, he suggested that energy was not emitted or absorbed continuously. Instead, energy could only be exchanged in small, discrete packets. He called these packets quanta. According to his idea, the energy of each quantum depended on the frequency of the radiation and was proportional to a new fundamental constant, now known as the Planck constant. This proposal was revolutionary because it challenged one of the basic assumptions of classical physics. For centuries, scientists had believed that energy could vary smoothly and continuously. Planck's theory suggested that nature operated in tiny individual units at the microscopic level. Although he initially introduced the concept as a mathematical tool to solve a specific problem, the implications of his idea would prove far more profound. Planck's quantum hypothesis successfully explained the blackbody radiation spectrum and matched experimental observations with remarkable accuracy. Over time, other scientists recognized the significance of his work. In 1905, Albert Einstein applied the concept of energy quanta to explain the photoelectric effect, providing further evidence for the quantum nature of light. Later, researchers such as Niels Bohr, Werner Heisenberg, and Erwin Schrödinger expanded these ideas into a complete framework known as quantum mechanics. The birth of quantum theory marked one of the greatest turning points in scientific history. It transformed humanity's understanding of matter, energy, and the fundamental structure of the universe. What began as Planck's attempt to solve a radiation problem became the foundation of modern physics. Today, quantum theory underlies technologies such as computers, lasers, semiconductors, medical imaging systems, and telecommunications, demonstrating the extraordinary impact of Planck's groundbreaking discovery. Contributions to modern physics. Max Planck's contributions to modern physics are among the most significant achievements in the history of science. His work fundamentally changed humanity's understanding of matter, energy, and the structure of the universe. Before Planck's discoveries, physicists relied on classical theories developed by scientists such as Isaac Newton, James Clerk Maxwell, and others. While these theories successfully explained many natural phenomena, they could not account for certain behaviors observed at the atomic and subatomic levels. Planck's groundbreaking ideas provided the foundation for a new era of scientific understanding. Planck's most important contribution came in 1900 when he introduced the concept of energy quanta. While studying blackbody radiation, he proposed that energy is emitted and absorbed in tiny discrete packets rather than as a continuous flow. This idea challenged centuries of scientific thinking and introduced a completely new way of understanding physical processes. Although Planck initially viewed this concept as a mathematical solution to a specific problem, it soon became clear that it represented a fundamental property of nature. A key element of Planck's contribution was the introduction of the Planck constant, one of the most important constants in physics. This value established the relationship between the energy of a quantum and the frequency of radiation. The Planck constant became a cornerstone of quantum theory and remains essential in modern physics. It appears in countless equations that describe atomic and subatomic behavior. Planck's quantum hypothesis inspired a generation of physicists to explore new ideas about matter and energy. Albert Einstein expanded Planck's work in 1905 by applying quantum concepts to light and explaining the photoelectric effect. Niels Bohr used quantum principles to develop a new model of the atom, while Werner Heisenberg and Erwin Schrödinger later created the mathematical framework of quantum mechanics. These advances were all built upon the foundation established by Planck. One of the most important outcomes of Planck's work was the development of quantum mechanics. This theory transformed our understanding of atoms, electrons, and subatomic particles. Quantum mechanics revealed that the microscopic world operates according to principles very different from those governing everyday objects. It explained atomic structure, chemical bonding, and the behavior of elementary particles with remarkable accuracy. Planck's contributions also influenced the development of modern cosmology. Scientists studying the origins and evolution of the universe frequently use concepts derived from quantum theory. The Planck scale, named in his honor, represents a set of fundamental units used to describe conditions at the earliest moments of the universe. These ideas continue to guide research into the nature of space, time, and gravity. The practical impact of Planck's discoveries has been enormous. Many technologies that define modern life rely on quantum principles. Semiconductors, transistors, lasers, computer processors, solar cells, and medical imaging systems all depend on concepts that originated from quantum theory. Without Planck's pioneering work, much of today's technological world would not exist. Beyond specific discoveries, Planck changed the direction of scientific thought. He demonstrated that nature contains deeper levels of reality than previously imagined and encouraged scientists to question established assumptions. His willingness to follow evidence wherever it led opened the door to one of the greatest scientific revolutions in history. Today, Max Planck is remembered as the founder of quantum theory and one of the architects of modern physics. His contributions continue to influence scientific research, technological innovation, and our understanding of the universe. More than a century after his groundbreaking work, the impact of his ideas remains as powerful and relevant as ever. Challenges, perseverance, and leadership. Max Planck's life was not only defined by scientific achievement, but also by the many challenges he faced and the remarkable perseverance he demonstrated throughout his career. His journey shows that great discoveries often require patience, resilience, and the ability to remain committed to one's goals despite obstacles. In addition to his contributions as a scientist, Planck emerged as an influential leader who helped guide the scientific community through some of the most difficult periods in modern history. One of the earliest challenges Planck encountered was the belief among many physicists that the field was nearly complete. When he chose to study physics, some professors advised him against it, arguing that most important discoveries had already been made and that only minor details remained to be solved. For a young student, such advice could have been discouraging. However, Planck was driven not by the promise of fame, but by a genuine desire to understand the laws of nature. His determination allowed him to continue pursuing physics despite these warnings. Another major challenge arose during his research on blackbody radiation. The problem was extremely complex, and many scientists had failed to find a satisfactory explanation. Planck spent years studying the issue, carefully analyzing experimental data and searching for a solution. Progress was often slow, and the existing theories of classical physics could not explain the observations. Rather than giving up, he continued working with patience and persistence. His perseverance eventually led to the revolutionary idea of energy quanta, which became the foundation of quantum theory. Planck also faced resistance from parts of the scientific community. New ideas are often met with skepticism, especially when they challenge long, established beliefs. His proposal that energy is emitted and absorbed in discrete packets contradicted the traditional view that energy changes continuously. Although his theory successfully explained experimental results, many scientists initially struggled to accept its implications. Planck remained committed to the evidence and allowed time for further research to demonstrate the value of his discovery. The personal hardships in Planck's life were even more difficult than the professional challenges he encountered. He lived through periods of immense political instability, including World War I and World War II. Germany experienced social upheaval, economic hardship, and widespread destruction. These events affected every aspect of life, including scientific research and education. Planck also endured profound personal tragedies. Several members of his family died during his lifetime, causing him immense sorrow. Among the most painful losses was the death of his children. Such tragedies would have overwhelmed many individuals, yet Planck continued to fulfill his responsibilities as a scientist, teacher, and leader. His ability to carry on despite personal grief demonstrated extraordinary strength of character. Throughout these difficult years, Planck became an important leader within the scientific community. He served in prominent academic organizations and worked tirelessly to support scientific research. He believed that science should remain dedicated to truth and knowledge, even during times of political conflict and social unrest. His leadership helped preserve scientific institutions and encouraged cooperation among researchers. Planck's leadership style was based on integrity, wisdom, and respect for others. He was known for his fairness, humility, and commitment to ethical principles. Colleagues admired his ability to remain calm under pressure and make thoughtful decisions during challenging circumstances. The story of Max Planck's challenges, perseverance, and leadership provides an inspiring example of human resilience. His life demonstrates that success is not determined solely by talent, but also by the courage to overcome obstacles, remain faithful to one's principles, and continue moving forward despite adversity. Through his determination and leadership, Planck not only transformed physics, but also left a lasting example of character and dedication for future generations. Influence on future scientists. Max Planck's influence on future scientists extends far beyond his own discoveries. While he is best known as the founder of quantum theory, his greatest legacy may be the inspiration he provided to generations of researchers who expanded upon his ideas and transformed modern science. His work created new pathways of investigation, encouraged innovative thinking, and laid the foundation for many of the most important scientific advances of the 20th and 21st centuries. When Planck introduced the concept of energy quanta in 1900, he opened a door to a completely new understanding of nature. At the time, many scientists were uncertain about the significance of his proposal. However, a number of brilliant young researchers recognized its potential and began exploring its implications. Among them was Albert Einstein, who used Planck's quantum concept to explain the photoelectric effect in 1905. Einstein's work provided strong support for quantum theory and demonstrated that Planck's ideas could be applied far beyond the problem of blackbody radiation. Planck's influence continued through the work of Niels Bohr, who developed a quantum model of the atom in 1913. Bohr's theory helped explain how electrons move around atomic nuclei and why atoms emit specific patterns of light. This breakthrough marked an important step in the development of modern atomic physics and would not have been possible without the foundation established by Planck. Other scientists also built upon his discoveries. Werner Heisenberg developed the uncertainty principle, which revealed fundamental limits on how precisely certain physical properties can be measured. Erwin Schrödinger created wave mechanics, providing a mathematical framework for describing quantum systems. Paul Dirac combined quantum theory with relativity, leading to important advances in particle physics. Each of these scientists was influenced directly or indirectly by Planck's pioneering work. Beyond specific scientific theories, Planck inspired future researchers through his approach to science. He demonstrated the importance of intellectual courage and the willingness to challenge established ideas when evidence requires it. At a time when classical physics seemed complete, Planck was prepared to consider a radically new explanation for experimental observations. This example encouraged later scientists to remain open-minded and pursue truth, even when it led to unexpected conclusions. Planck was also an influential teacher and mentor. Throughout his academic career, he taught students and supported young researchers who would later become leading figures in science. His lectures were respected for their clarity and depth, and many students benefited from his guidance. By fostering an environment of learning and inquiry, he helped nurture the next generation of physicists. His influence extended through scientific institutions as well. Planck played an important role in Germany's academic community and supported organizations dedicated to research and education. After his death, one of the world's most prestigious research networks was named the Max Planck Society in his honor. This organization continues to support groundbreaking scientific work across numerous disciplines and reflects the lasting impact of his commitment to knowledge. The technologies that shape modern life also illustrate Planck's influence on future scientists. Researchers inspired by quantum theory developed semiconductors, lasers, transistors, computers, medical imaging devices, and countless other innovations. These achievements demonstrate how Planck's original ideas continued to guide scientific progress long after his own lifetime. Today, Max Planck remains a symbol of curiosity, dedication, and scientific excellence. His discoveries inspired some of the greatest minds in history and helped create entire fields of research. Through the scientists he influenced and the knowledge they produced, Planck's legacy continues to shape our understanding of the universe and drive the advancement of human civilization. Lasting legacy and impact on the modern world, Max Planck's legacy extends far beyond the scientific achievements of his own lifetime. His groundbreaking work laid the foundation for quantum theory, a field that transformed humanity's understanding of nature and became one of the most important pillars of modern science. More than a century after his revolutionary discoveries, Planck's influence continues to shape scientific research, technological innovation, education, and our everyday lives. The most significant aspect of Planck's legacy is the creation of quantum theory. Before his work, scientists believed that energy was emitted and absorbed continuously. In 1900, Planck proposed that energy exists in tiny discrete packets called quanta. This idea challenged the traditional assumptions of classical physics and opened an entirely new chapter in scientific history. What began as an attempt to explain blackbody radiation eventually developed into quantum mechanics, one of the most successful scientific theories ever created. The impact of quantum theory on modern science has been enormous. It provides the foundation for our understanding of atoms, molecules, electrons, and subatomic particles. Scientists use quantum principles to study the behavior of matter at the smallest scales, helping answer fundamental questions about the structure of the universe. Fields such as atomic physics, particle physics, condensed matter physics, and quantum chemistry all rely on concepts that originated from Planck's work. Planck's influence is also visible in the technology that surrounds us every day. Modern electronics depend heavily on quantum mechanics. The development of semiconductors and transistors, which are essential components of computers, smartphones, and countless electronic devices, was made possible through an understanding of quantum behavior. Without Planck's pioneering ideas, the digital revolution that transformed communication, business, education, and entertainment would not have occurred in the way we know it today. Lasers represent another important example of Planck's lasting impact. Laser technology is used in medicine, telecommunications, manufacturing, scientific research, and consumer electronics. From internet communication systems to surgical procedures and barcode scanners, many modern technologies depend on principles that emerged from quantum theory. Medical science has also benefited greatly from Planck's legacy. Technologies such as magnetic resonance imaging (MRI), advanced diagnostic tools, and various forms of radiation-based treatment rely on discoveries rooted in quantum physics. These innovations have improved healthcare, enhanced disease diagnosis, and saved countless lives around the world. Beyond technology, Planck's legacy includes his influence on scientific culture and education. He demonstrated the importance of intellectual honesty, careful reasoning, and a willingness to challenge accepted beliefs when evidence demands it. His example continues to inspire students, researchers, and educators who seek to advance human knowledge. Universities and scientific institutions around the world teach concepts that trace directly back to his discoveries. One of the most visible symbols of his enduring influence is the Max Planck Society, a world-renowned research organization dedicated to scientific excellence. Named in his honor, it supports groundbreaking research across numerous disciplines and continues the spirit of inquiry that defined Planck's career. Today, Max Planck is remembered not only as the founder of quantum theory, but also as a visionary whose ideas reshaped civilization. His discoveries transformed science, enabled revolutionary technologies, and expanded humanity's understanding of reality itself. The modern world is deeply connected to his work, ensuring that his legacy will continue to influence future generations for many years to come.